Hello, it's Eugene, and it is a short review of the final version of my voltage converter. At first, let us see its dimensions. They are 65 on 40 millimeters, and this is twice less than the area of this probe version of the converter. I reached it with removing auxiliary circuits here. Also, I replaced the output capacitor. It is 1 microfarad here, and in the final version I used 470 nanofarads, and it is enough for this circuit. And the last thing, I used 3 legs instead of 4 legs, so saved a little area by this. Okay, as always in my constructions, I mount leaded components, for example deep cases, and transformer on one side of the PCB, and SMD components on the other side. It quickens the mounting procedure. Power switch is IRF 540 in DPAC or TO252 case. It has a short flange which can be soldered directly to the PCB. It is a very useful feature because it saves some area, and also it ensures enough heatsink. I must say that I frequently see in internet how some Gauss builders use huge heatsinks. They mount, for example, TO220 cases or even TO247 cases of their power switches to these sinks, and I think it is not necessary in our circuits, because if you calculate the heat mode of the transistor in the right way, it will never break, because our mode of work is peak, it is not continuous. And if you make mistake, otherwise, the heat processes are very fast, and the transistor will blow up in milliseconds, and this huge heat sinks will not help you. For example, I don't know if you see it, this is a power switch which has blown up. You can see its chip has vaporized with a part of the case, so don't do mistakes. Okay, this is the I used current breaker in a wire, within a wire mounting. It is a very handy thing. I used it because I utilized battery supply from battery, not from stationary power supply. Why did I do it? For example, if you find stationary power supply with 12 volts and 25 or 20 amperes, it will give you 300 watts of power. And if a current limitation works, it must be not less than the maximum peak current of the transformer of our converter. And this peak current is about, as I said, 20 or 25 amperes. So if we have, for example, short circuit somewhere, our limitation will give you 300 watts in this point, and it will blow up. Okay, so the power supply current limitation will not save us from this situation. and the current breaker will do it. And this connector is very tight, so not to distract it with frequently on and off action, I used simple switch. It is 20 amperes rated. It's more than enough for this circuit. Okay, now let's test it and see what we get. Okay, I have mounted testing rig for the converter. I used battery of electrolytic capacitors. It is the same battery used for the previous version of the converter. It consists of 7 capacitors, 450 volts and 470 microfarads each. The only thing added is a resistive divider. I used it for investigation with the help of oscilloscope. By the way, I will place a short article on my site dedicated to this investigation. There you will see oscillograms of voltage rising on the batteries, on the capacitors, and other things. Okay, and as usual for this converter, power supply is divided into power itself, power part from one battery, and the digital part of another battery. Okay, now we will try to charge this battery and see how it works. Alright, let us start. Okay, it's 418 volts. Oh, by the way, I've forgot to say that this version of converter is with negative output voltage. It means that I connected the output of the converter with the ground leads of the capacitors, and accordingly the ground of the converter is connected to the plus of capacitors. So we have minus 416 volts now on the output of the converter. Okay, let's turn it off and discharge it. Okay, discharging begins. And here are the PCBs for the other versions of these converters. They are built on the same scheme. In fact, these are copies of these converters. I will use them in my next coil guns, because I think that this is a very good scheme. I like it. Okay, that's all. Goodbye.